Okay, I hope I'm audible to all students who are attending this particular practice lecture for mathematical methods for economics. If all students can recall that in my previous practice lecture based on functions in several variables, we had looked at some practice problems based on the concept of partial elasticities. We had learned how to find the direct partial elasticities and the cross partial elasticities of demand. And I had done some good numerical problems in the previous lecture as well. Now, in this particular lecture, I continue with some more practice problems based on the concept of partial elasticities. But now in this particular lecture, I'm going to focus on production functions. In the previous lecture, we had looked at demand functions and how to calculate partial elasticities from demand functions. In today's lecture, we are going to look at how to calculate partial elasticities given the production function and concepts based on that. So let's quickly start with this particular lecture. So I'm just writing the main heading for completeness. We are looking at practice problems. We are looking at practice problems based on functions in several variables. Practice problems based on functions in several variables. Okay, so now let's quickly write the heading partial elasticity of output. So all students who are attending this lecture, practice lecture, can write the heading partial elasticity of output. Partial elasticity of output. So let me first go over a bit of theory before I jump to numericals, just to revise with all students. Let x, which is a function of k and l, denote a production function. Denote a production function where x denotes output, k denotes capital, and L denotes labor. Then eta XL is the partial elasticity. Eta XL denotes the partial elasticity of output X with respect to input L, which I can write as L over X times del X by del. Eta XL is going to capture the partial elasticity of output with respect to the input L. It's going to capture by what percentage will the output change when the labor input changes by a certain percentage. Or I can say it also captures the degree of responsiveness of the percentage change in output with respect to percentage change in labor. I can also write it like this. I can also write it as del log X over del log. This is the alternate formula to find the partial elasticity of output with respect to the input L. Then similarly, I can write eta xk is the partial elasticity of output X with respect to the input K, where K denotes capital. Formula K over X times del X by del. Alternate formula del log X over del log. So this is going to capture the degree of responsiveness of the percentage change in output with respect to a given percentage change in the capital input. So these are the formulas for partial elasticities of output with respect to the labor input and the capital input respectively. Okay, now let's look at a practice question based on this. So if I erase all this off, students can now write the heading practice question. Let's look at a practice question. So given the Cobb-Douglas production function, this is something we do in our microeconomics course, in our intermediate microeconomics course. Consider the Cobb-Douglas production function where output X is produced using the following function: A L to the power alpha, K to the power beta, where all of us know that X denotes output, L denotes labor, and K denotes capital. Okay, the question asks us find the partial elasticities. Find the partial elasticities of output with respect to the labor and capital. Okay, so let's quickly solve this particular question. So we are given the production function. Consider the production function X, which is A L to the power alpha, K to the power beta. Okay, if I have to find out partial elasticity of output with respect to labor, so I can write partial elasticity of output, which is X with respect to labor, is given by eta XL. Formula is, we have just done it. It is del X by del L times L by X. Now from this particular production function, I can quickly find del X by del L. If I work out del X by del L, it's A alpha L to the power alpha minus 1 K to the power beta. Just a quick recap: when I'm partially differentiating X with respect to L, I treat K as a constant. Okay, so I can write, therefore eta XL is going to be del X by del L is this whole term. So I can just write A alpha L to the power alpha minus 1 K to the power beta times L over X is A L alpha K beta. A cancels. Okay, K to the power beta, K to the power beta cancels. I get alpha. L to the power alpha minus 1 multiplied by L gives me L to the power alpha over this L to the power alpha. This and this cancel out, I get alpha. And what is alpha? Alpha is nothing but the share of labor in output. If you look at alpha, so I can say the partial elasticity of output with respect to labor can be interpreted as the relative share of labor in output. The relative share of labor in output. Because if you look at eta XL, it has come out as alpha, and alpha itself is nothing but the relative share of labor. It is the relative share of labor in output. It is the relative share of labor in output. Similarly, if I calculate the partial elasticity of output X with respect to capital stock K is given by eta xk. Formula is del X by del K times K by X. If I quickly work out del X by del K, I partially differentiate the production function with respect to K, treating L as a constant. I get A beta L to the power alpha K to the power beta minus. So therefore, eta xk is going to be del X by del K is this whole term. So I can just plug it here. A beta L alpha K beta minus 1 times K over, what is my X? X is nothing but my production function. A L alpha K beta. A and A cancel out. L to the power alpha cancel out. I get beta. K to the power beta minus 1 multiplied by K is just K to the power beta over K to the power beta. This and this cancel out. I get beta as my answer. And beta is nothing but I can write relative share of capital in output. It captures the relative share of capital in the output X. So I can erase this initial part off, and I can write it here that the partial elasticity of output X with respect to capital K can be interpreted as the relative share. It can be interpreted as the relative share of capital in output. It can be interpreted as the relative share of capital in output. So I hope all students attending this lecture have understood how we have solved this particular problem. Okay, now let's look at the next application. So if I erase all this off, the next application is based on the concept of marginal utility, which we do in microeconomics. So I can write partial derivatives. I can write the heading partial derivatives and utility in economics. Let's look at the application of partial derivatives to utility in economics. Okay, so I can write given, this is first of all, I'm making all students write the theory first. Given the utility function u, which is a function of x and y, where x and y are commodities, and u is the level of utility, I can say del u by del x, also called as MUX, denotes the marginal utility. In microeconomics, it denotes the marginal utility of commodity X. So it's going to capture that if I increase the consumption of commodity X by 1 unit, by how much will my utility change? To be more precise, if I consume an additional unit of good X, by how much will my utility change? Is captured by marginal utility of commodity X. Similarly, I can write del u by del y, also called MUY, denotes the marginal utility. It denotes the marginal utility of commodity Y. Marginal utility of commodity Y. It is going to capture that keeping commodity X constant, if I increase the consumption of commodity Y by an additional unit, by how much will my utility change? I'm repeating it again, guys. MUX is going to capture that keeping the consumption of commodity Y constant. If I increase the consumption of commodity X by an additional unit, what will be the impact on utility? Is captured by MUX. MUY is going to capture that keeping the consumption of commodity X constant. If I increase the consumption of commodity Y by an additional unit, by how much will my utility change? Let's look at a practice question based on this particular concept. So practice question. So the utility function, we are given the utility function of a consumer is given by u, which is equal to 200x plus 300y plus 15xy minus x square minus y square. We are given this utility function of the consumer. The question asks us find the marginal utilities. Find the marginal utilities of x and y when x takes the value 100 and y takes the value 5. That means suppose the consumer is consuming 100 units of good x and 5 units of good y. We need to calculate the marginal utility of the consumer at these particular points. So first of all, given the unity function 200x plus 300y plus 15xy minus x square minus y square, let's first of all calculate MUX and MUY. Now MUX is nothing but the partial derivative of the unity function with respect to good x, which is 200 plus 15y minus 2x. Remember, when I'm partially differentiating the function with respect to x, I treat y as a constant and I differentiate it. So MUY will just be del u by del y, which is the partial derivative of the unity function with respect to good y, which is 300 plus 15x minus 2y. Now, if I calculate the marginal utilities, MUX at 100, 5, and x takes the value 100 and y takes the value 5. Just put x as 100 and y as 5, so it becomes 200 plus 15 into 5 minus 2 into 100. This is 200 plus 75 minus 200, which is 75. And likewise, MUY at the value 100, 5 will be put x as 100 and put y as 5. So I get 300 plus 15 times 100 minus 2 times 5, which is 300 plus 1500 minus 10. It comes out as 1800 minus 10, which is 179. This is the marginal utility of commodity Y at the given point. So hoping all students have understood this and have no doubts. Okay, so I stop in this particular lecture. The objective of this lecture was to discuss with all students some other applications in economics when it comes to partial derivatives. We have looked at partial derivatives and the production function. We have calculated the partial elasticities with respect to capital and labor. And then we have also looked at partial derivatives and utility function, which we do in microeconomics, where we have calculated the marginal utilities with respect to commodity X and Y respectively. Okay, now in the next lecture, in the next practice lecture for this series, I'm going to look at the concepts of marginal product. I'm going to look at the concepts of marginal product plus marginal revenue product. Again, something which comes from the production function and is an application of partial derivatives. So we are going to look at this. I'm also going to look at the concept of marginal cost in the next lecture. Plus, I am also going to do some numericals. Numericals based on these concepts. So all this I intend to cover in the next lecture. So I hope all students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.